Uh-oh. What are those? Oh, poop knuckles. Hello, Internet. My name is Quinn, and this is Blondihacks. Well, the devil went down to Georgia, and he was looking for a soul to steal. He was in a bind because he was way behind, and he was willing to make a deal. When he came across this young man, sawing on a fiddle and playing it hot, the devil jumped up on a hickory stump and said, "Boy, let me tell you what. I guess you didn't know it, but I'm a fiddle player too. And if you'd care to take a dare, I'll make a bet with you. Now you play a pretty good fiddle, boy, but give the devil his due. I'll bet a fiddle of gold against your soul, because I think I'm better than you. And well, the devil is better than me, at machining and almost certainly playing the fiddle. They say you learn the most from your mistakes, and if that's true, we're going to learn a lot this week, because we're back on the PM Research steam engine, and we're doing the main bearings. Let's go." That took so many takes. Oh, I think that was the one. It's time to machine the bearing caps, and I took a look at the drawings to make a game plan here, and they seem very straightforward, except one little thing caught my eye. There's a little bit of a lip. The bottom of the bearing cap is not flat, like I assumed it would be. Now the faces on the base where the caps sit are flat, so what's going on here? I couldn't square these two pieces of information. Is there an error in the drawing, or what's going on? If we switch over to the exploded view of the entire engine, we can see that the bearing caps are shown here with flat bottoms. So that was starting to make me think that there's an error in the other drawing. But exploded views like this sometimes show simplified versions of the parts, so you got to be careful about assuming too much from this. But I still had an inconclusive situation here. And then I took another look at the drawing for the base casting, and I saw what I was missing before. There actually is a little bit of a step shown in this drawing here. There's a 31 thou depth of shoulder that I'm supposed to make there, and you can see it in the section view at the top here as well. So this tiny little detail is what I missed when I machined the top surfaces of this casting. And that's a little bit unfortunate because it means I have to do that setup again and try to get it to exactly where I had it so I can machine those reliefs in there. And in hindsight, of course, that makes perfect sense. You want the bearing cap and the base to key together independently of the bolts so that they maintain their alignment after being bored. Bolts are never good for maintaining alignment between parts. They're only for clamping parts together. You need some kind of a key or a registration that is what maintains the alignment. So it's usually pins or some sort of, in this case, a shoulder. So we're going to set this guy up like we did for cutting the bearing landings and make that little relief. So if you've been watching this series, you will recognize this setup. I'm putting my 1, 2, 3 block in the vise, and then I'm going to fixture the casting to the vise, and then I indicate on the casting there to get it square to the mill, and the block is square to the mill via the vise, so they are square to each other. And then I can get the angle blocks in there and set the angle of the 1, 2, 3 block, and thus the casting. So I'm using the 1, 2, 3 block as a little fixture plate here. Now I'm indicating in to see how close I got it to flat, and thus how close I got it to matching the previous setup, and I didn't expect this to be great, and it's not. So I could either get out the tense indicator and try really, really hard to get this perfect, or instead what I've decided to do is I'm going to get as close as I can with the half thou indicator, and then I'm just going to remachine the top surface here. I can take a couple of thou off of these landings without adversely affecting any of the dimensions in any serious way, and then I just know that I'm once again working with properly flat surfaces for where the mill is now. You may also recall that these landings are different sizes, so I'm once again measuring them, and I'm doing my best to try and figure out how to center the recess on the two landings so that they end up in the same place and kind of split the difference on error, because one of these landings is about 20 thou taller than the other one. So I'm edge finding on this edge of the casting here, which is not a great idea. Edge finders don't work very well on a rough surface like that, but I just really didn't have a better idea. So it seemed to work okay, but I then marked where the recess was going to go with some Sharpie layout there just to kind of sanity check things before I make any cuts, and that looks like it's going to work. It's centered, it's the right width, and well, let's go. I then proceeded to touch off and make passes across both landings to cut the recess. And I'm taking very light cuts here because the setup is certainly not rigid. You know, it's just being held by a little bit of the vice jaw there. So a little bit sketchy, but luckily this cast iron is very easy to cut and this seems to be going quite well. So I'm going down to the final depth that I want for my recess, and then I'll work my way across side milling. I should be close to final depth now, so I'll check, and we are at 22.5 thou. We're aiming for 31. But, well, that's reassuring. It's nice that the Quill DRO agrees with how far down we've gone, so that means I can finish up this dimension and trust the DRO. Next, I switch over to incremental on the DRO and zero that, and I'm going to use that to track my progress horizontally across the relief. And so I just side mill my way across to the final width that we need. And clean up our toys, and that is looking pretty good. So we'll need to deburr that a little bit, but I think we may have succeeded in this. I'll check that final width with my adjustable parallels. We're aiming for 500 thou, and we're at 501, so I think that's going to work okay. We can machine the bearing caps to fit. So now I'm trying to figure out how wide the bearing caps should be, and the two cast landing areas there are different widths, so I'm doing my best to kind of split the difference. And I'm going to start by filing off some of the bigger chunks on the sides of the casting here to give us something reasonable to machine. I thought I'd machine the edges first, so that will allow me to hold it square for the top and bottom, and I'm using a piece of copper there to take up the casting imperfections. I'm just going to do 1 or 2 passes so that it's mostly cleaned up, but I'm not going to get aggressive about trying to clean it up. And then I'm going to flip it over and do the other side because I'm trying to kind of average the error in the casting and end up with something that's straight and cleaned up on both sides, and there isn't a lot of extra material here on this casting. So I'm kind of going back and forth. And you can see that I've still got the edge of the sprue showing there, but we've got one side almost cleaned up. So I'm just kind of going back and forth, one edge to the other, trying to take as little as I can off each edge and kind of work my way in towards the final shape of the bearing that is hiding inside that casting. You can see that I didn't quite make it. There's still some edge of the sprue there that didn't clean up, and on the opposite corner I've got some low spots there. So let's talk a little bit about what's happening here. Now normally when you're squaring up stock, if you're working with bar stock, you've got some crazy shaped piece of stock like this, and what you're doing is you're trying to find the perfect shape that's inside that stock of the dimension that you want. And it doesn't really matter how the block is oriented when you start, as long as you've got enough margin for error inside to machine all those surfaces down and have them all clean up. So you've got lots of wiggle room there, and the orientation of the original block doesn't matter very much. Now what I'm learning the hard way here is that working with the casting is different because the casting has its own shape, and the orientation of that shape needs to be maintained even as you're trying to find the machined version of it inside. So what I've done here is machined a version of this shape that's a little bit crooked inside the casting. So in addition to not having a lot of extra material to work with, unlike bar stock, it really does matter what the starting orientation of that casting is, and you need to do your best to get it straight. I did a much better job of this on the base casting than I did with these little parts. With these little parts, the error of the casting surface just overwhelms the size of the part, the dimensions that you're trying to align. So it's pretty difficult to get these things straight. But I brought them both to this point and they're okay. But what is the airspeed velocity of an unladen swallow, I wonder? So next I'd try and machine the bottom, but I didn't have the right size parallels, and the size that I have, I couldn't get a really good grip on the sides with the vice jaws, so instead I thought I'd try using my toolmaker's clamps here to set this up. So put a 1, 2, 3 block in there to act as kind of a fixture plate, clamped the toolmaker's clamp on the machined sides, and then clamped the clamp down to the 1, 2, 3 block, and then got it level with an indicator to the best of my ability, just kind of tapping it in. And again, this is a little bit of a fool's errand because the casting is so rough relative to the size of the part that it's very difficult to tell if you're level or not, even within 5 thousandths. But we have to do our best and take a shot at it. So now I can go ahead and clean up the bottom with a 1/2 inch end mill. In this dimension, we don't really have anything specific that we're trying to hit. The drawing just has a recommended thickness for the final casting in the area where the bolts go through. So I'm checking that. And I'm actually about 10 thou over size here, so I'm going to leave it that way because it's going to give me some wiggle room if I mess up some dimensions or something later on. And to be clear, when I measure this, I'm including the registration that we're going to have to machine here, so some of that material is going to go away. But that's looking pretty good. So now I'm going to try to machine the ends, and I was pretty happy with that toolmaker clamp setup that we just used, so I'm going to use it again. I think it'll be even more useful on the ends because I couldn't come up with a good way to hold it this way in the vise. So I'm clamping it in the toolmaker's clamp and then using a 1, 2, 3 block as kind of a backstop to keep the part precisely vertical. It's going to want to tend to rotate in that clamp because as the cutter spins, that's going to try to push the top edge of the cutter backwards. So here I did the same technique as I did for the long edges, where I machined just kind of a little bit off of each end and kind of went back and forth trying to split the difference and remove as little as possible from each end while also squaring up each end, and always keeping an eye on my final dimension to make sure I don't go under. I've really been impressed with this PM Research kit, but if I had one complaint, it's that there's really not enough extra material on these castings. Here you can really see that effect I was talking about with getting the casting crooked. The opposite corners of this guy didn't clean up properly, and that's because I didn't have it perfectly straight as relative to the error that's in the casting. But at least size-wise, we're doing okay. So, this engine is going to be a runner, not a looker. Now maybe you've been yelling at your YouTube player this whole time, but I didn't notice until just now, after getting the bearing caps fully machined, that this registration area for the bearing caps is not centered. I don't know what happened here, to be honest. I double checked that math. I did my little sanity check with the Sharpie and the scribe marks, and I did everything to make sure that this landed in the right place, and it didn't. So I think this counts as my first error of substance on this project, and I'm sure it won't be my last. The good news is this error, I believe, is recoverable. Let's talk about how. So here are the mounting bolts for the bearing caps, and you see that they're going to go in this little flat area here. And the good news is there's actually plenty of meat here. So this area here ended up the same width as my bearing cap, and the curved area is wider than my offset recess. And the other bolt's going to end up back here. So what I'm going to be able to do is just enlarge my recess area so that it's centered. And it's still going to end up actually very reasonable. My recess area will be about the width of the arch section of the bearing cap here. So I think that's actually still going to work out just fine. But it does mean setting this up again to widen this slot. I'm not super excited about doing that. The dimension for that recess specified on the drawing is 500 thou typical. And, well, I've never been accused of being typical. I'm going to end up about 550 thou here, so certainly blew that dimension, but I think it's still going to work out just fine. As long as we're staying within the meat of the castings until we bore the crankshaft, we can get away with a lot. So I think what I'll do is I'll machine the positive side of that registration interface on the bearing caps first, and I'll make sure it's centered on the caps, and then whatever width it ends up being, I'll enlarge this area here to match. So it's going to be a lot of extra setup that I shouldn't have had to need to do, but at least the mistake is recoverable, so I'll take that over scrapping a casting any day. I love it when random things fit together. My scale is presently a perfect fit in those recesses. Man, that's weirdly satisfying. I'm going to set up to drill the bolt holes now, so I'm edge finding to get a center line, and I'm setting up an end stop here so I can repeat this setup with the other casting. I did manage to get the 2 bearing caps within 1 thou on length with each other, so that's good. So there's my position for the first corner, and I go ahead and center drill all 4 of those. And then I'm coming back in with the clearance drill size specified in the drawing. These are, I believe these are number 348 bolts, and so they're pretty small. And so these clearance holes are, by extension, quite small. I've got one parallel running down the middle there, so I don't hit it with any of these holes. And that looks like that's going to be a great fit. So next I'm going to do a little spot face around each bolt hole, just so that the head of the bolt has somewhere smooth and nice to sit, as is called for in the drawing. And if the shape of the casting gets a little bit too close to the bolt hole, this also clearances it a little bit so the head will sit down flat. And that's looking pretty good, except for the, crappy machining around the outside edges. But for my very first ever set of bearing caps from a casting, I'm pretty happy with that. Now I'm going to machine the registration on the bottom, and This is the point where I remembered that I have adjustable parallels, and so I can actually use those to get the exact depth that I need in the vice jaw and not have to use that wacky toolmaker's clamp setup. Now, if I told you that I was not just looking for excuses to use the toolmaker's clamps that I made, that would be a lie, so I'm not going to say that to you. Now, I really probably should have done these registrations at the same time as I machined the bottom all in one setup without moving anything instead of redoing the setup like this. This will turn out to be kind of the theme of this project. We're ready to mill the step on the bearing caps now, but how big should we make that step? I know I want to expand the size of this relief area here to get it centered, but how big should it actually be? I measured this top section on both sides, and they're fairly different. There's about 20 thou difference there because the casting on this side is quite a bit taller than on this side. So I have no choice really but to split the difference between the two and end up with an average sized top landing. Now the bearing caps are both the same size, so given a certain size top landing, subtracted from the overall length of the bearing and trying to leave the same size average bottom landing, I end up with a relief width here of 558. So I'll measure a step that long centered on the bearing caps, then set this guy up again and enlarge these reliefs to match. And by now you've probably figured out what I eventually also figured out, or perhaps much sooner than I figured it out, that I've made machining the bearing landings here on the base so much harder on myself than they needed to be. The big mistake that I made from the beginning was I should not have done any work until the bearing caps were completely done. I should have machined the bearing caps to this stage, including with the step in the bottom, and then set this guy up once and machined all of the features in this area, including tapping and drilling and every single feature on these caps in one setup. Instead, I'm forcing myself to set this up on this tricky area over and over and over again, partly because of mistakes, but also partly because I just didn't plan ahead enough on this whole section. Machining really benefits from planning ahead, and this isn't just convenience, it's also precision, right? Because every time I redo this setup, I'm never getting it exactly where it was. I'm introducing a few tenths or even a couple thousandths sometimes of error every time I redo this setup. So each of these features is accumulating error from previous passes. So much like you saw me do with the bearing caps, once I get this guy set up again, I'll probably remachine all of these features, take another couple of thou off of them, so that once again all the features have been made in one setup as it should be, instead of trying to reproduce a previous setup with any degree of precision, especially on such small surfaces, is really difficult, and I've made my life much harder than necessary, but we'll press on. You can see that I've done some layout there, and I'm double checking it by eye with the end mill there to make sure I'm going to cut the right place here. I'm a little paranoid now after having done all of that measuring and indicating and somehow still ending up with the wrong sized and positioned recess on the bearing lands, but that seems to have turned out very well indeed. And then once again I had to do this setup as I showed before, and this time, similar to last time, I just decided to take a very fine cut off of all of these surfaces, just about 2 thou, just to make sure everything is coplanar rather than trying to get these small surfaces perfectly aligned to within a tenth, which is what I would kind of need to do to make sure that everything is going to end up in the correct place. So now I'm just enlarging those recesses to fit the bearing caps, and that looks great. That's a really good fit. I've got no slop in that. The registration is really nice, so I think that's going to work. Now for the threaded holes, I would normally transfer punch them like this, but because this is kind of suspended in the air at a funny angle in the vice jaws, I'm almost certain to move it by trying to hammer on those with transfer punches. So instead I'm going to use a drill to align the holes, but unfortunately I don't have enough vertical space to do this. This mill is very small. But luckily I have a spare set of cheap drills here, so I cut the end off of one, made it shorter, and now I can get in over the part. So now I'm super gluing the bearing caps in place, and then give that a minute to set up, and now I can line up the drill on my clearance holes. Now this isn't going to be perfect because drills tend to cut over size, so the drill that just made these clearance holes is going to be a little bit of a loose fit. And then I can use this drill to drill a little divot in the bottom of each of these holes, and then when I come in with the smaller tapping drill size, it's going to be centered on those clearance holes. I dug my little compressor out of storage to blow these holes out because I'm going to tap them now, and it's very important that there be no chips in there. These are tiny holes, and it's very easy to break a tap with something this small. But that worked really well, and now a test fit there with the supplied hardware from the company, and everything looks good. So this seems like a victory. Well, Murphy is not done with me yet on this part. Do you notice anything here? Anything at all? You see this little impression right here? That's actually a cast-in boss. It's just barely higher resolution than the casting sand, so it's just an impression. This is supposed to be drilled and tapped for oil cups. Those need to point up. Guess where this boss is? That's right, when this engine is sitting on the ground, that boss is pointing down. Now, interestingly, I got them both backwards, so, I had a 1 in 4 chance of doing that. So, at least 2 wrongs kind of made a right here. I have 2 choices. I can either just ignore those bosses and drill and tap them up here once the time comes. And that would honestly be fine. These bosses are barely visible anyway. I could even file them off a little bit or something. But in principle, these bearing caps should flip end for end. I mean, I did drill the bolt pattern on the DRO, and I used the DRO to center the relief there. So in principle, they should reverse. The bolt pattern might not be perfectly centered on the casting, so it's possible the edges won't line up in a way that I like after flipping them, but I'm going to flip it end for end and see what happens. A little bit of heat will break that super glue, and then I can pop those caps right off of there again. Well, that didn't work out. It was really close. I could see in there that a couple of the bolts were just a little too close to their clearances. I probably could have made them fit, maybe open up 1 or 2 of the holes by like a thou or 2. The bolts line up so perfectly in the orientation in which they were drilled, as you would expect, so I'm going to leave it like this. I believe that the misalignment is down to the match drilling that I did. When I was doing that match drilling, there was, 4 or 5 thou of error possible in that. You never get it exactly right when you're trying to match an existing hole with a drill. The hole is a little oversized, and drills are flexible, so if it's a little off, you may not notice it and it'll still drill the hole. And so there's plenty of room for 4 or 5 thou of precision error in each of the match drilled holes. And when you accumulate it over a 4-hole pattern, it's very easy for one of the 4 to be a little off. I'm going to count myself lucky that I screwed them both up in the same way, so they at least match. I was literally not paying attention to those bosses at all. I completely forgot they existed. And so I just wasn't paying attention, and I had a 1 in 4 chance of getting them to line up in the incorrect way. I had a 50-50 chance of them being in the same place and 1 in 4 chance of them being like that at least. So it could have been worse. I'm going to ignore them once they're painted over. I don't think they'll be too noticeable, and they'll be on the bottom. And then I'll just drill and tap up here for the oil caps. I'm going to do that after I bore the crankshaft, however, because it'll be easier to drill and tap through into the crankshaft bore once that's done. So I think I can take it down out of this setup now. I'm frankly terrified to do that after having set it up here 3 times, but I think I'm ready to do that. It's time to bore this crankshaft. The 2 most important things about the crankshaft bore is that, of course, the crankshaft is extremely square to the axis of the engine so that there's no binding anywhere when this thing is spinning and the crosshead is moving. And the other is that the 2 bores are extremely well in line with each other. They need to be as perfectly coaxial as we can get them so that the crankshaft sits straight or square, as it were, to the engine, and there's no binding or unusual wear or run out created in the ends of the crankshaft, things like that. Now, a really great way to do this sort of thing is line boring, and that's where you fixture the work on the cross slide of your lathe, for example, like this. Now, of course, you would have packing so that the bore that you're cutting is coaxial with the lathe. But imagine this guy is sitting up here, and then you make a tool, which is a bar that sits between your chuck and a live center, let's say, or it could be between centers and you could drive it with a dog, or in any case, you have a spinning bar in here that has a cutting tool in it like a boring bar. And then you can drill this out approximately, and then you run the boring bar through the bore and you feed with the carriage. And you've probably seen this done on much larger scales on other YouTube machinist channels. It's a really cool operation, a very unusual use of the lathe, and I really, really wanted to do it for this crankshaft bore. However, I don't think it's practical. The issue is size. So this is a 3/8 end mill, and so this is the diameter of the crankshaft. You can see how small that is. So to create a line boring tool that was smaller than that and also had room for a tool bit to come out of it to spin and do the boring, I mean, everything would just have to be so tiny and there'd be no rigidity in any of that. And I don't think you could successfully line bore at such a small scale. So as cool as that is, and as much as I wanted to try it, I think we're just going to go much more straightforward. We're going to drill it and we're going to ream it. Home stretch now. Let's set up to drill the bearing itself. So I've got a mock-up here on the bench to make sure I'm going to have the clearances that I need around the angle plate and everything. And off comes the vise, clean everything up. If you watched the previous video in this series, you know that I learned that this angle plate is not especially square. It's off by 1 thou and requires shimming to be square in this vertical dimension. So now that's good and square. I really should take this angle plate to a surface grinder and have it properly squared up. Well, that's a bummer. I got this thing dialed in so beautifully within a couple of tenths in both dimensions. And I was getting ready to mount this guy up here. You can see here I got the spindle lined up with where we're going to drill the crankshaft bore. The problem, however, is that the crankshaft bore is located from this surface right here. The drawing specifies the distance to the bore from this surface right here. And you can see that we don't have the reach to edge find on that surface. So we have to be able to set this up this way, or we'll never have the range of motion needed on the table to do what we need to do. And as we saw earlier, I cannot set the angle plate up this way because I don't have enough depth on the throat of the mill to clear the back of the plate and still reach out far enough to do the operation. So I could probably get away with orienting the angle plate this way and mounting the work on the back, but then I'm working on the back of the angle plate and I can't see what I'm doing. So I'm going to try something else. In the back of my mill tooling drawer, I found this little baby angle plate that I forget why I bought this, and I have never used it. It still had cosmoline on it, but it's going to be, I think, just the thing here. So I've bolted it in place with one bolt there, and I'm getting it horizontal, indicating on the crosshead slides there, and then I'm doing my best to squeeze a second bolt in there for support. I'm also putting a machinist jack just under the lip of the bearing cap there to give it a little resistance against the drilling forces. Okay, moment of truth. So I'm indicating on the x-axis using the spot-faced cylinder mounting point, and then on the y-axis using the bearing slides. And then from there, using the numbers on the drawing, I should be able to get over to where the bearing needs to be drilled. Now we're drilling right on a split line here and kind of an uneven casting. So I used an end mill to make a flat spot there, and then I center drilled the center of that. Now I'm going to pilot drill it, and here's a random little tip. I'm using a weird size drill. This is 11/64. Why am I pilot drilling with a weird size? Because a weird size has probably had little or no use, and so it's going to be very sharp and have a good factory grind on it, and that will help it go very straight. So when a pilot hole is really important, I don't use my 1/4 inch because that's had a hard life and has been poorly reground by your gentle hostess multiple times. Now I'm opening it up in preparation for reaming. You'll notice the other challenge I'm having here is I don't have enough quill travel to drill all the way through in one go, so I drill the top bearing, and then I have to lower the head and drill the bottom bearing, and then I have to raise the head to get the drill clear of the work. It's one of the challenges of such a small mill. We're ready to ream now, and I bought a special reamer just for this job. It's a spiral fluted reamer, which is really important because this hole has axial split lines in it, right? The bearing split lines. And you can't use a straight fluted reamer in a hole like that because the straight flutes will snag on those edges and the reamer will either wander off course, cut over size, cut out of round, something like that. So spiral fluted reamer, very important for a job like this, though they are quite a bit spendier than the straight fluted kind. Now I'll do a test fit here with an end mill just to get some sense of if the hole is okay. The space is too tight in here to test fit with the actual crankshaft, but at least I can get a sense before I take it all apart and deburr this hole and deburr the inside as well using that Noga inside deburring tool. Now for a test fit, I'm going to measure the shank on the reamer here, and this guy is about 6/10 under size, so this will be a good test. And that fits really, really well, and it spins just beautifully. There's no play, but it spins freely. Now this reamer shank is 6/10 under, which is about what the crankshaft is going to be as well, so that should be just right. And then I'm checking for squareness with my precision Starrett square here, and it's a little bit tough because of the short distances involved, but it looks perfectly square as far as I can tell by shining a light under it, so I think this should be really good. The last thing my little bearing caps need is the mounting hole for the oilers. There's a little oil cup that sits on top of each of these bearings and just very slowly drips oil into the crankshaft. and it's just a simple threaded hole that needs to be straight up. And this could be really tricky because, you know, these bearings are a weird shape and they're sitting at a weird angle, and the cup needs to come out perfectly straight when the bearings are mounted as they are here. And well, we'd need some sort of crazy fixture to make that all work out just right. Yep. If only we had some kind of thing that held the bearing caps at just the right angle when they're installed on the machine. To position the oil cups, since I don't have the bosses for reference, I just centered them. Just using the machinist scale, it's going to be good enough. And I just center drilled them and then drilled them the tapping size. And now we can tap them. Now, this is the smallest tap I own and the smallest tap I've ever used. It's a 256, a number 256. Very, very small, so chance of breaking it pretty high. At least it's a through hole though, so blind holes, you know, pack up with chips very easily, and it's much easier to break a tap in that situation. But you can see that I'm using just my fingertips. I'm not using the full length of the tap wrench, just to minimize the leverage, and then backing out frequently to make sure the chips don't pile up. And I'm very happy with that end result. That looks good. Okay, but real moment of truth. How did the bore line up on the bearing area? Well, you can see that this one is pretty good. It's not perfectly centered. It looks like the bearing land, I should have machined it a little bit more than I did, because that would push the bore up and back a little bit and center it perfectly on the cap there. But it's okay. The other side, however, is definitely worse. And I think what probably happened here is the bearing lands are not machined equally. So probably the casting was not perfectly vertical when I had it set up to machine these lands. And so one land is a little higher than the other, is my guess. So it looks like the crankshaft is crooked, but of course it isn't, because it was drilled straight through. And I showed with the stare square there that the crankshaft is straight and square to the cross slide bearings. This is really just an aesthetic problem. You know, once the caps and everything are installed and you bore it straight through, the bore is going to go where it's going to go, and it's going to be straight relative to the motion of the engine, but it may not be straight relative to the castings. So, you know, like I said earlier, this engine is, I guess, going to be a runner, not a looker, and I learned a lot doing this. This is my first time trying to machine anything like this, and there's like 15 things that all have to go perfectly for that crankshaft to land in exactly the right place on both sides of this casting. But the engine, I think, is going to run really well. The crankshaft feels really good. It's really straight. So let's press on. I hope you enjoyed watching this, and we'll see you next time.